Good morning, ladies and gentlemen. This is Mr. Rowe. I'm going to talk to you about how to use the graphing calculator to solve a system of equations. This is something you'll have to use for Algebra 1 and Algebra 2. So let's take a look at how we're going to use the graphing calculator here. So if you have your TI-84, make sure you have it out. Make sure you have it turned on. There's three methods for solving a system. The first method is to solve by graphing. And we can solve by substitution, solve by elimination. So I'm going to show you how to definitely do it by graphing. And I'm going to show you how to check your work when you're doing elimination or substitution. So here is an example of a substitute of a graphing system. So we're going to graph both of these systems. So to graph a system in the TI-84, we're going to go to y equals, which is right here, this top button. And we're going to type these equations in just like they are. Now, the button that you're going to use for your variable x is right here. You don't have to put in y because these are already y equals. So I'm going to type this in. So that'll be 4 divided by 5. And this button right here is our variable x minus 3. Okay, and I'm going to hit enter to go to the next equation and do the same thing for this one. And this is the negative button. Don't use subtraction, use this negative button. So negative 6 divided by 5x plus 7. And so now to take a look at the graph, you just hit the graph button right here, and you see the graph pops up. Now, if you want to place these graphs in your work, which is one of the things you're going to have to do when you solve by graphing, you're going to hit second graph. And see, this pulls up a table of values that you can then use to plot points on your graph. So y1 would be the first equation we typed in, y2 would be the second equation. So we can match up x and y. So, for example, if I wanted to graph this equation, I've got a point at 0, negative 3. So I'm going to plot a point at 0, negative 3, which is down here. I've got a point at, and I'm looking for whole number points. I can't plot 2.2. I'm going to scroll down until I find a couple other points here. I've got a point at 10.5. Oh, there's one right there, 5.1. I can plot that point. So 5.1 is right there, and then 10.5 is right there. You see those lines line up nice and straight. Now I can graph those lines. I can just draw my graph. Let me do that. I'm going to draw my graph right through those best I can. There we go. That's graphs. And I'm going to do the same thing for the other line. So I'm going to scroll back up and look for some points here. So on this one, I've got 0, 7 I can graph. So I'm going to change to blue here. I said 0, 7, right? So there's 0, 7. I've got 5, 1. Look at that. That's our point of intersection right there. So once I find my point of intersection, I don't really need to find any other points. So I'm going to go ahead and just draw that line. And so there's the point of intersection. Now remember that for a system, you have to identify the solution, which is right there. And that point would be 5, 1. The solution to a system is an ordered pair. So now, what if it wasn't a good point? What if that wasn't a lattice point, as we call it? How do I find the solution without, finding that point of intersection like that? So I can tell the calculator to find the point of intersection for me. So to tell the calculator to find the point of intersection, I'm going to calculate something. So here's a calculation function right here. So I'm going to hit second, trace, and then what I'm looking for is the intersection of these two lines. So that's option 5 right here. And now what it's going to ask me is first curve, second curve, yes. First curve would be the first line. So I'm just going to hit enter because you see my cursor is already on the first line. So I'm going to hit enter. And it says second curve. Well, look, it jumped up to the other line. So I'm just going to hit enter again. Then it's going to ask me to make a guess. I don't want to guess. I want the calculator to do it for me. So I'm going to hit enter again. And look, it pops up with the answer 5. So those steps, you're going to hit second, trace. And you're going to choose option 5, which is the intersection. And then you're going to hit enter 3 times. So that's how we're going to do these. Now I'm going to take a little bit less time on the rest of these. Just wanted to walk you through that complete first example here. So now this system, the reason I gave you this one, this is a different form. This is standard form, ax plus by equals c. Now how am I going to use the graphing calculator to help me graph this? Well, there is a little translation formula that we can use. So I don't even have to sit there and change this to slope-intercept form. I can just translate this right in the calculator. And it's going to be ny equals, you're going to do parentheses, c minus ax divided by b. So for this first one, which is 4x minus 5y equals 15, in y1, I'm going to type parenthesis 15 minus ax, which in this case would be 4x, close the parentheses, hit the divide button, and then whatever b is. B is the number in front of y. So include the signs. That's going to be -5. So that's what I'm going to type in to y1. So I'm going to go back to y equals. So I'm going to clear out any equations that are already there. And then I'm going to go back to y1 and type in this first equation. So 15 minus 4x, close the parenthesis, divide by -5. Let me slide this back over so we can see how that looks. All right, so that's 15 minus whatever that is, 4x, close parenthesis, divide by whatever b is. I'm going to do the same thing for the next one. I'm going to open parentheses, and I've got a -45 right there, so -45. I don't need to close my parentheses yet, Mr. Rowe. Pay attention. I'm going to subtract ax, which is 2x. I'm going to close my parenthesis. I'm going to divide by whatever y is, or whatever b is. So that's +5. And then I'm going to hit my graph button. And you see there's the point of intersection. I can see it on the screen. Another important thing with these is that you have to be able to see the intersection on your screen. Otherwise, a lot of times you'll get something called a no sign change error. So then you need to make your window bigger so you can see it. If you hit the window button, a lot of teachers, when I learned how to use the graphing calculator, would tell me to just go ahead and make these very big numbers so that you never have this issue. So I make this -100, this 100, this -100, and this 100. That way you never have an issue with seeing your intersections. That's up to you if you want to do that, but I'm not a fan of that. So, because I like to be able to kind of make a good guess as to what I'm going to have when I'm going to do my next function. So now I'm going to find this intersection. I'm not going to graph this. I already showed you how to do that. So hit second graph to find those points. So now I'm just going to ask the calculator to find the intersection for me. So I'm going to hit second, trace, option 5, which is intersect. And then I'm going to hit enter 3 times. 1, 2, 3. And look at the intersection right there. -5, -7. So that's how you're going to use this graphing calculator to help you graph these equations or check your work. Now, let's take a look at this next example. We've got 3 more examples to look at. I'm going to go through these a little more quickly. This would be an example of a problem where you're asked to solve by substitution. So now, if you're asked to solve by substitution, you need to show your work for substitution. But you can check your work using the graphing calculator. So here's my graphing calculator again. I'm going to go back to y equals. I'm going to clear those equations out. I'm going to type these equations in just like they are. So negative 3x plus 4, 7x minus 6. See, I'm doing this very quickly. And then I'm just going to ask it to find the intersection. So second trace, option 5. Let it pop up. And it's going to say first curve, second curve. Yes. 1, 2, 3. Look at the point of intersection is at 1, 1. You can check your work very quickly using this graphing calculator. If you didn't get 1, 1, then you know you need to revise your answer. Right, so let's take a look at our last 2 examples. I need to erase all this. I have to redo my recording. So, all right, so this system, you see we have one equation that's in standard form. We have one equation that's in slope-intercept form. Well, at this point, we know a little translation formula. Let me write that down for you again. You might want to write this down and practice with it. It's parenthesis C minus AX divided by B. So use that translation formula anytime you have an equation in standard form. So y equals, clear these out. Now, first equation is in standard form, so I'm going to use this translation formula right here. I'm going to open a parenthesis. C is negative 13. I'm going to subtract whatever AX is, so 7x. Close my parenthesis, divide by whatever B is, which is 2. Second equation is already in slope-intercept form, so I can just type it in. So negative 8x minus 20. Okay, I'm going to hit the graph. Make sure you see your intersection. I do see my intersection, so I'm just going to hit second trace, option 5, which is intersect, and I'm going to hit enter 3 times. 1, 2, 3. And there it is, negative 3, 4. And finally, we'll take a look at this one. This would be a system that you would use elimination for, the third method. So, to show your work for elimination, what I would do on this one is just add these equations together to cancel out x and then find y, and then substitute to find x. So, clear. Then I'm going to use my little translation formula. My translation formula here for the first one, open parenthesis. I've got 30 minus 10x, close parentheses, divided by whatever b is. B is negative 5, so negative 5. Enter. Second equation, open parenthesis. I've got negative 24 minus whatever AX is, so negative 10x. So that just keeps me from making any kind of mistakes in signs. Divided by whatever b is, which is 2. I'm going to hit my graph, see if I see my intersection. And yep, I see it right there. So I'm going to hit second trace, option 5. Enter, enter, enter. Now look, our point of intersection is 2, negative 2. So I hope this helps you use the TI-84 or 83, same rules for 83, to solve a system of equations. Now this is a system of linear equations. For Algebra 2, you'll have systems of linear equations and systems of quadratic. So I can put out a little short video if you need that for that. So let me know in a teacher message if you still need help, or make an appointment for a help session.